Z1 and Z2 both are given in terms of polar form. So as we saw, there are three types of representation of a complex number: Cartesian form, the polar form, and the Euler's form. This representation, which has a cis in it, is called the polar form. And just for revision, let me write down the elaboration of cis theta. Cis theta is nothing but cos theta plus I sine theta. Cos theta will be the real part of the complex number, and the sine theta is the imaginary part of the complex number. So as you saw that these are just the cis representations, or basically the polar forms. The question is, find the value of z1 cube, and one instruction is already given that we need to transform our answers in this form, and as we know, this is called the Euler's form. So we want to go from polar form to Euler's form. And just for revision, remember cis theta is nothing but e to the power I theta. So e to the power I theta is also cos theta plus I sine theta. Now, before we do this question, so we have Z1 cube. Let us understand the concept of De Moivre's theorem. Okay, one sec. All right. So here we go. So have a look. Let's understand the De Moivre's theorem. Z is equal to mod Z cis theta is, of course, our polar form or the modulus argument form. If you raise both sides of the equation to the nth power, your equation will become like this. And then that's where comes the De Moivre's theorem. So understand, whenever you are raising cis theta to any power, that power gets multiplied with theta. And that's why n and theta are together. So this is multiplication. And that's why eventually you get z to the power of n equals to mod z to the power n into cis n theta. So the key here is you need to multiply the power with the argument, right? Same logic we will apply here. So it's z1 cube. So let's write down. Z1 is equal to 3 cis 3 pi by 4, which is already given. Now, if you cube both sides of this equation, let's do that. Z1 cube will become 3 cube, and the whole cis thing will become cube. Now, 3 cube is 27. Now, according to the De Moivre's theorem, remember, whenever a cis function is raised to any power, so the power gets multiplied with this argument. So we will write cis of the power 3 multiplied by the argument 3 pi by 4. So our z1 cube becomes 27 cis 9 pi by 4. So that's the answer. Before we finalize, you need to be careful and look at the instructions again. The instruction was give your answer in the form of REI theta, which is the Euler's form, keeping in mind that the value of theta, the argument, needs to be in this range, minus pi to pi, right? So step one, this is still the polar form. Let's convert this in the Euler's form, the E form. So the z1 cube will become 27 e to the power of I into 9 pi by 4. Now observe this, 9 pi by 4 definitely does not fall in this particular range, minus pi to pi. As you can see, 9 pi by 4 is greater than pi. How do we make sure that the argument is in the given range? You either add or subtract 2 pi. So in this case, let's try to subtract. 9 pi by 4 minus 2 pi. If we simplify this, let's see, what do we get? Simple algebra will get us pi by 4. Now this pi by 4 definitely falls under that particular range, minus pi to pi. So your final answer for z1 cube needs to be 27 e to the power of I into pi divided by 4. So that's the answer for part 1 of this particular question. Now moving ahead to the second part. So analyze the given data, and the second subpart of the same A part. Find the value of z1 by z2 raised to the power of 4, and for a value of n is equal to 2. Now to do this, let's revise some properties of cis functions. So have a look. Whenever you have two cis functions which are getting multiplied, so the end result is cis theta plus phi. Similarly, if we divide two cis functions, the arguments get subtracted. So we use this property over here. First, they have already given put n is equal to 2. So let's put n is equal to 2 in place of the z2. So z2 will become 2 times cis. N is 2. So to simplify, the z2 becomes 2 times cis of pi by 8. Now what we need to do is we need to divide z1 and z2 and then we raise them to the power of 4. So let's do that. Z1 upon z2. Z1 is 3 times cis 3 pi by 4 as it's mentioned in the question. Z2 we found out 2 times cis pi by 8. Now we use the property of cis. So remember cis theta by cis phi is equal to cis theta minus phi. So the z1 by z2 becomes 3 by 2 cis 3 pi by 4 minus pi by 8. And if we simplify this, we should get a cis of 5 pi by 8. If you take the LCM, we will get 5 pi by 8 as our answer. That's the argument. Now we are not done yet. We have to raise the entire thing to the power of 4. So let's do that. We'll write z1 upon z2 raised to the power of 4 will become 3 by 2 to the power of 4 cis of 5 pi by 4, and this is also raised to the power of 4. So the fourth power of 3 is 81 and the fourth power of 2 is 16. Now in the cis function, we have to use the De Moivre's theorem. So if we remember, whenever a cis function is raised to any power, so the power gets multiplied with the given argument. So we will write cis of 4 into 5 pi by, sorry, I have made a mistake. This is 5 pi by 8, not 5 pi by 4. So let's correct that. So it was 5 pi by 8. And now we can raise the entire cis parameter to the fourth power. And now on simplification, the final result will become 81 upon 16 cis of 5 pi by 2. But remember the original instructions, we have to convert in the Euler's form, keeping in mind the theta should satisfy or rather fall in the particular range. So let's do that. So our final answer should be, it is 81 upon 16 e to the power of I 5 pi by 2. We are almost done. So 5 pi by 2 is the argument, but it doesn't fall in that particular range. So we subtract 2 pi, right? So let's do that. 5 pi by 2 minus 2 pi. If we take the LCM and simplify, we'll get pi by 2 as the argument. So our final answer should be 81 by 16, which is the magnitude modulus, and the argument is pi by 2. And that's the answer for the second part of A.